All right, here we go. You may recall that the number of worker weeks is directly proportional to the amount of work that can be done. So problems 1 through 4, we are to round the 2 decimal places unless the answer comes out even in fewer than 2 places. 2 decimal places means there are exactly 2 digits to the right of the decimal point. Doesn't matter how many there are to the left of the decimal point. So suppose 9 painters can paint 13 houses in 11 weeks. Use that rate to work the first 4 problems. How many houses can 25 painters paint in 42 weeks? Well, again, 9 painters, 11 weeks is 9 times 11, and they can do 13 houses. So how many houses? I don't know, but 25 painters times 42 weeks is painter weeks divided by X number of houses. So in all cases, we're going to have the same thing on one side of the equation. 9 times 11 times 13, based upon the fact that 9 times 11 is 99 painter weeks, can do 13 houses. How many houses can 25 times 42 painter weeks do? Well, let's see. Cross multiply 9 times 11 times x must equal 25 times 42 times 13 in any order you want. So then x, I just like to work from here, but this is me personally. X is going to be 25 times 42 times 13 divided by 9 times 11. If you want to do that, you can either divide by 99, which is 9 times 11, or you can divide by 9 and divide by 11. Sometimes one is more convenient than the other. But if you want to multiply these two things together and get 99, and 25 times 42 times 13 is 13,650, that's absolutely fine. Problem number 2. How many painters are needed to paint 100 houses in 26 weeks? Okay, painters times time, 26 times X painters must equal 9 times 11 divided by 13. Cross multiply, we get 13 times 26X equals 100 times 9 times 11. And again, we can divide 100 times 9 times 11 by 13 and then divide it by 26. Or we can multiply all these out instead and divide 9,900 by 338, which is what 13 times 26 is. Either way, you get the same answer. And notice 2 digits to the right of the point. We write out 3 digits to see if that third digit is big enough to bump up the second digit, and it has been the case so far. How long will it take? That's time. 50 painters for X number of weeks. So painters times time, 50X over 250 must equal, again, 9 times 11 over 13. Cross multiply, 13 times 50X equals 250 times 9 times 11. So X must be 250 times 9 times 11 divided by 13 times 50, or divided by 13 divided by 50. If you want to write out those products, you can divide them that way. You'll get exactly the same answer. Number 4, how many painters? I got 250 houses in 48 weeks. So worker time, X painters times 48 weeks, 48X. Again, 9 times 11 over 13 must equal 48X over 250. Cross multiply, 13 times 48X must equal 250 times 9 times 11. So X must be 250 times 9 times 11 divided by 13 and then divided by 48, or you can write out those calculations and divide it by whatever they turn out to be. In this case, 13 times 48 is going to be 624, and 250 times 9 times 11 will be 24,750. On to a little percent. Eddie Rapido bought a pool table for $10,255.50, including tax. So what does that mean? That means that this number has the tax in it. This number is some other number plus 7.5% of that other number added on. So using algebra, if X is the price before tax, then the price before tax plus the tax, which is the tax rate times the price before tax. And again, this is 1x and 0.075x. When you add them together, you get 1.05x. Next problem. Okay, she's got to put some money in the bank. And if she leaves it in for a year, it will give her 3% interest. Leaving it in for a year is what simple interest means, not compounded monthly or bi-monthly or daily or any of that stuff. She puts some money in, leaves it in a year, she gets her money back plus 3%, but it's not 3% of 1,500. So don't do that and subtract that from 1,500 because how much money she puts in is unknown. But the amount deposited is X, let's say, and when you add 3% of X, you want that to equal 1,500. Again, this is 1x plus 0.03x, which is 1.03x. Divide 1,500 by that, and you get 1456.310. I put one more digit out there in case I'm rounding to the nearest penny, but guess what? It says round answer to the nearest dollar. And if you don't do that, well, you're going to lose points. So let's not lose points over something that you can really avoid pretty easily. Number 7. Okay, you got some donuts for $6.95, tax included. Tax rate is 7.8%. How much is tax and how much is used to pay for the actual donut? I've asked 2 questions that requires 2 answers. Let X be the price of the donuts before tax, so that X plus the tax rate times X. Change to a decimal, of course, 7.8% is 0.078. And again, that's 1x plus 0.078x, which is 1.078x. That's 695, which we divide by 1.078. Now we write out 6.447, one more digit than pennies, because we need to determine the nearest penny. And if it's money, I always want you to use the nearest penny unless it says the nearest something else, like the nearest dollar or the nearest $100. But the 7 is big enough to bump that up to 645. You can calculate, now that's the actual donuts. You can calculate the tax by simply subtracting the donut price from the full $6.95 price, and that's $0.50 or 50 cents, but not 0.50 cents. 0.50 cents is a half a penny. And if you want, you can multiply the cost before tax by the 0.078 tax rate and get, again, 50 cents. Notice that the realtor gets 7% of the selling price, and that is not 7% of the 180,000. So a lot of people do, they'll take 7% of 180,000 and add that on to 180,000. It's not going to work because that bigger number is what the realtor gets the 7% of. So what you have to realize is that if the selling price is unknown, but you know what you want to have after you pay the realtor, then the X dollars that it's selling for, take away 7% of X, that is just like adding, only this time you're subtracting. If you're doing 1 minus 7% is not 0.7, it's 0.07, you get 0.93. Oh, that's pretty cool. So 93% of the selling price must be the other 180,000. So you divide that out. And this says to round it to the nearest penny, but if it didn't, you would still round it to the nearest penny. In this case, I put that one more digit out there beyond the pennies to determine if it's 38 cents or 39 cents, and 7 is, sure enough, big enough. Here's a problem that we can work in several ways. We've seen this before on page 5 with follow-up on page 7, 8, and 9. And that would be a good reference if you see one of these problems again. So the out the door price is $15,975.60, and that figure includes $630 in fees. Oh, well, let's see. Let's subtract the fees out then, and we get $15,345.60 because they're not taxed. It also includes 8% sales tax. So again, the actual cost of the truck is 10% less than the sticker price, but we don't know what that was. We'll hold on to that 10% less for a little while. But whatever it is, when you add 8% of it, that's when you get the $15,345.60. And again, that's 1.08x. So you divide by 1.08 and you get that, which rounds to $14,208.89. But that's not the sticker price. This is the price after 10% of the sticker price has been discounted. So if Y is the sticker price, Y take away 0.1Y, that's 10%, is equal to that number, and that's 0.9Y. So we take $14,208.89 and divide it by 0.9, and we get $15,787.655. which just barely rounds to 66 cents. If you want a shorter version, here's a cute little formula. Take 15,975.60, 15,975.60, and you can put the 0 or not, and subtract 630 from it, and hit the equal sign, because you don't want to be dividing just the 630 by the next step, 15,345.60. And where is that? Okay. Then I divide that by 1.08. And I get that. Now, if I don't round it off here, so if I don't round off until the end, if I just leave that alone, which is usually what you do, I'm going to divide that by 0.9, which represents the 90% that's not discounted. And I'm going to be a little different. It's going to be 65 cents instead of 66 cents. So 15,787.65. Well, 1 penny is not going to matter for such a big amount. It does matter if it's donuts for a few bucks. So I would take either one of those. Okay, so Cookie wants to take some money out of her IRA to have $6,400 cash after the government gets 27% of the amount withdrawn. This is key. The government does not get 27% of 6,400, because that's not going to leave enough money for her to have 6,400, because when you take 27% of the amount withdrawn, which we don't know, let's call it X. So the amount withdrawn, take away 0.27 times that. I want that to leave 6,400. And again, 1 minus 0.27 is like $1 minus 27 cents. That's 73 cents. We divide 6,400 by 0.73, and we get 8767 after we round it off. Why do we round it off to the nearest dollar? Because it says so. If it did not say round off to the nearest dollar, if it did not say round off to anything, it would be 12 cents out there, 8767.12. Now here's the grade distributions, which is a really good treatment of this. The problem's on page 5 or 6, I guess, and I think on page 7 and 8 we get the answers. This is a nice little summary. 7 plus 9 is 16, plus 17 is 33, 36. There's 37 grades. You take each of these numbers, 7, 9, and so on, divide it by 37, and it says to round the answer to the nearest 0.1%. What that means is change this to a percent, 18.91, and I have that extra digit because that digit's going to tell me whether to leave it 18.9 or to bump it up. Well, it turns out 18.91, the 1 is not big enough. If it were a 5, then you can't make a 9 into a 10 because we got only 1 digit can fit there. So we would make it 19.0 if that 1 were a 5, 6, 7, 8, or 9. So 9 divided by 37 is 24.32%, and the 2 is not big enough to make it 24.4. 17 C's turns out to be 45.94. And again, the 4 is not big enough, but if it were a 5, then it would be 46.0%. Because of 9, you can't put a bigger digit than that. And 3D's are 8.1%, 8.10, and the 1F is 2.70, and the zeros were not big enough to bump it up. And that, ladies and gentlemen, hopefully will shed a little light on all this.